Hello everyone and welcome back to my channel. So in today's video we are going to work with the Cisco Network Service Orchestrator, also commonly called as the NSO. So before we discuss the Python code, let's understand that NSO, what an NSO actually does. So imagine that I have a network containing routers, switches, firewalls and devices running different operation systems. So I might have a Cisco IOS device, a Cisco IOS XR, a router, and XOS switches. So if I want to automate these devices individually, I would need to know how to communicate with each platform and how its configuration works, right? So that is where the network service orchestrator comes into the picture, right? Now what you see over here is basically the sandbox that I have opened last time, like we opened for Cisco Meraki. So today we have opened the sandbox in a similar way for the Cisco NSO lab, right? So the environment will be created something like this, right? You have to launch the environment, you have to use the username and password that is provided to you under the IO tabs, and from there you can go ahead and log into the Cisco Network Service Orchestrator and start the work, right? So if you go to the Cisco Network Service Orchestrator, log in over here and check the device section, you would be able to see the devices, right? So when we say network service orchestrator, so what does the word orchestrator means? So basically the orchestrator sits above the individual network devices and coordinates operations across them, right? So instead of my automation program directly managing every individual device, NSO provides a centralized orchestration layer, right? So conceptually we can think about our environment like this. It's like a Python sitting on top of the application, which is Cisco NSO, and from there it is basically managing the various devices, right? So the application can communicate with the NSO, the NSO handles the interaction with the underlying network devices, right? Now let me showcase to you the devices that I'm showing on this. You can also log into the sandbox through the same username and password, but through the SSH, so you can use PuTTY for that, right? And now if you give the command in the Cisco Network Service Orchestrator, so I'm already logged inside the Cisco Network Service Orchestrator, but here I was showing you the same devices from the front end. I'm going to show you the same devices from the back end. So if you give the command show devices list, so in the Network Service Orchestrator you will be able to see the same devices that were visible over here, right? Now here we can see that it is managing roughly around, I don't know, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15, I think 15 devices it's managing, right? And notice something interesting, we have different devices types over here, right? We have iOS XR, we have switches, we have firewalls, we have routers, we have ASAs. So different kind of devices can be managed from here. So rather than our Python program having to directly deal with all these different devices types with different IP address, we can leverage Network Service Orchestrator to communicate with all the devices, right? Now there is also something called as the basically the NED ID, right? So what is the NED ID? The NED ID actually stands for the network element driver, right? So the network element driver provides the NSO with the driver specific knowledge needed to communicate with the different types of network elements. So NSO can work with different platforms while presenting a consistent management model to the application using NSO. Now let us do the device check sync. Basically that is used to check whether the NSO's configuration is synchronized with the actual devices or not. So I'll go ahead and I'll type devices check sync, right? Sorry, the spelling is incorrect. I'll have to put this up. Okay, it's incorrect again, my apologies. Yeah, so now you can see that some of the devices or most of the devices you would see as in sync. However, you would see that one of the devices, which is that RT01, is basically the device that is out of sync. Otherwise, whichever device you would see, all the devices, whether it's a edge firewall, whether it is a switch, or whether it's a router 02, that is in sync, right? The other routers, right? So that means that the NSO has detected a difference between its configuration representation and the configuration currently associated with the device, right? Now, if I do devices, device, let us talk about the device that is out of sync. So if I just paste it over here, followed by compare config, we can see the configuration. We can see the difference in the DNS configuration and the logging configuration. And this is a good example of why an orchestration platform is useful, right? So NSO is basically not simply acting as a SSH terminal. It maintains a modeled representation of the network and can determine whether that representation is synchronized with the devices. Now the today's objective, which we always do, is the uh, uh, the script that we create, right? In my case, the script is already created, right? We are going to just talk about it, right? Because it's a 241 lines of code. I will share the link of this particular code that I will be putting up in my GitHub, and you guys can go and look at it, right? So so far we have looked the NSOs from its CLI, but today the video is really about combining the NSO with Python. So I want the Python to retrieve the running configuration from all the devices. That is the goal which we want to achieve. So we will be fetching the particular configuration from the devices, and we will be storing it in a JSON format, and we will not be processing one device each at a time, but we will be concurrently retrieving the configuration from all the devices, right? So let's go with the code one by one, or okay, let's talk about the code only, right? So in the starting you can see that just give me a moment. Okay, so see the basic module that we are using over here is the request module, as always, that we are using in all our uh, uh, Python codes that we have written, right? The other one being the .env, right? And then you can see a new module that we have introduced over here, which is called as the concurrent features module, right? So uh, basically the .env, as you have seen in our previous videos and our previous codes, we were able to save the information, or save our secured our credentials in a secured format on the .env file, right? From where we are uh, loading the host name, the username, and the password. The other one is the request, which is used for the RESTful APIs, and the third one is the concurrent features that it will be required for the parallel processing, right? So now you can see that we have already loaded the parameters, or we have loaded the credentials from the .env file. For the sake of this particular video, I cannot represent the username and password because that's a sensitive information, and that's also a good coding practice that it should not be revealed. After that, you can see that I am trying to reach out to the once the load.env loads the value from my .env file, the os.get env will retrieve each value and store it in the Python variable. That will be about it, right? The SSL will be disabled in this case, so please note that we have currently disabled the SSL. Otherwise, we can face a lot of issues. And in production, it would not simply disable the certificate verification. I would configure Python with appropriate trusted CA certificate. That would be required, right? But for the sake of sandbox demonstration, I'm using verify is equal to false, because my local Python installation doesn't trust those sandbox certificate. So that is the reason, right? uh, okay, coming to the RESTCONF part. uh, Now let's talk about the Python, and which is communicating with the NSO. So we are going to use the RESTCONF. The RESTCONF is basically an HTTP based interface for interacting with the YANG model data. So our Python application can use normal HTTP request with NSO, and uh, if I talk about this, the inventory URL, which we are pointing out. So we are asking NSO for the device inventory from here, right? We are providing the authentication uh, which we have fetched from our environment variables. Then we are making the get request. So you can see the get request where we are passing the inventory URL, the authentication, which is basically our username and password, and the header along with it, and the SSL verification equals to false, and the total timeout, right? So I specified a timeout of 30 seconds so that my program doesn't wait forever if something goes wrong. Okay, so once we hit it, we'll get the response, and then we will try to process the response.json, where I finally convert the JSON response into a Python object over here, right? Then comes the next part where we extract the device names, right? See, I'm trying something new over here. I'm not trying to write the code, because when I try to write the code, basically it becomes very difficult to explain, and since it is a intent behind that, right? So when I write devices inventory followed by tail NCS device, the response contains the device information under the tail NCS device key. So I am extracting that particular list, and the list will be the Python list comprehension for every device returned by NSO. I am extracting its name, right? uh, then notice that I haven't hard coded these device names. The Python has discovered them dynamically from the NSO. We are not trying to hard code something over here, right? If the devices are found, we are just printing the statement that the devices have been found, and then we are printing each and every device. Now before doing anything parallel, uh, we try to fetch the running configuration for the device. So we have built a function, right? In the particular function, it will receive a particular device name, and when we construct a REST conference URL, right? So this is the REST conference URL for a particular device. So if the device is dist rt01, the URL contains device is equal to dist rt01, and then again the response, which will be having the requests.get, where we are sending the URL, the authentication, the header, and the SSL status false, and waiting for a total of 30 seconds, which is basically your timeout, getting the response, and then checking for the elapsed time, right? uh, so see, ideally how we should proceed about is that we should check for one device, and if in case it is successful for one device, uh, we have to check it for the multiple device, then we can go ahead. So before introducing concurrency, I always test the basic operation with one device. If this works, we know that our REST conference URL and configuration retrieval logic are correct. Now after that, we can slowly and steadily scale it to all the 15 devices, and then you can test it out, right? So now let's talk about hang on here for a second, and then talk about the problem with the sequential processing, right? So we could have simply used a normal Python for loop over here to fetch the details of each and every device, and then take the show run configuration, and fetch it all and put it into a JSON file. But that means that the program waits for one HTTP request to finish before starting for the next one, right? So device 1, you wait for it, it gets finished, then it goes on to the device 2, waits for it. Then once VFS the configuration finished, and then it moves on to the device 3, right? So network requests are inbound outbound operations while Python is waiting for a response from NSO, and we can use that time to work on the other request, right? So here comes the concept of the thread pool executor, right? Now when we talk about the thread pool executor, this is where the Python's thread pool executor comes in. So I am creating a pool with 5 worker nodes, right? So you can see that I have started to create the thread pool with maximum 5 worker nodes, and think of these workers as a 5 people who can independently make the network requests, right? So a thread pool worker is making the request to device 1, device 2, device 3, and device 4 and device 5 simultaneously, and then in the 3 shots or in the 3 loops it will be able to complete it, right? Now what we can do is, in the last one we are going to submit all the devices. So for device name, right, for each device name I am submitting the get running config. Okay, so see, this part is basically where I'm trying to save the JSON. Sorry, I forgot about this. We have to save all the running configuration to a particular JSON file, right? And the file will be opened in a JSON format, and then all the particular running configuration will be copied over here, right? And the final summarized information would be displayed over here, something like that, right? So if you see get running configuration, right? So this is what we are using to get the running configuration, and then we are fetching this running configuration and putting it inside the thread pool executor, right, where this particular function runs for 5 devices each at a time, and once this is completed it gives us the result as soon as the particular request finishes. Then we append the results, and if the result status is success, right, so basically we are appending it to the result section, and if the result is successful then we are printing the success result, the result of the device and the result time, and if in case it is failing then we will print failed with the resulting device and the resulting error, right? After that, in the final process, we'll take the okay, just give me a moment. So as completed is useful because the devices won't necessarily finish in the same order that we started. So let's say if test RTR01 finishes first, we can process its result immediately. We don't have to wait for the core RTR01 if the core RTR00 is open, right? So after that we are saving all the configurations to the JSON file, right? We like we rightly called out earlier. So we retrieve the device name associated with this future, and then the future dot result basically gives me the this let me highlight this, right? So it gives me the result returned by get running configuration, get running config function, right? So if the request succeeds, I store the configuration to my all configs dictionary. If something fails, then I catch the exception and report which device it has failed, right? So everything will be saved to the JSON, right? You can see that we are creating all running configs.json file over here. Once all the workers have completed, I have all the configuration for all successful devices in my Python dictionary, so I am saving that into a JSON file. So you can see that I have put up indent equal to 4, which makes the JSON easier to be read in a human readable format, you can say that, right? And final summary would be displayed something like this, right? So final summary will be successful, followed by the result will be displayed over here, right? Then NSO running configuration report will be there, total devices, successful, failed, total time, all that would be, displayed once the JSON has been taken up successfully on the Python script, right? So let me, since we have already run it, so I do not want to showcase you the, initial file. Let us go ahead and delete it over here, right? So we have now deleted it. Now let us, run this once again. Let me close this also. Okay, so I'll run this, and then you will see this again, right? So let's wait. Right, so see, now you can see that it has started to take the first it discovered the devices, then it found 15 devices in the network service orchestrator, then it fetched the running configuration for all the devices. Then you can see that this is the final running report, that it has fetched the configuration for all the 15 devices, failed for 0, and the total time taken to fetch the running configuration for all the devices which were saved to the running configs JSON is 3.7 seconds, right? So this is the current execution time. Now let us go to the file and showcase the file. So now you can see this particular core router information, what is the host it is carrying, right? The name server. So the entire information for the running configuration can be seen over here, right? And the schemas and data store, the Yang library model state, right? And then it starts for the other device or the other router, right? So that way you would be able to see the configuration for all the devices, right? This has been stored. So now let's review what we have built. So first, the NSO gives us the network device inventory. Python retrieves that inventory through the RESTCONF. We dynamically then extract the device names. We create one reusable function that retrieves the configuration of a device, and instead of executing that function sequentially, we submit the operation through a ThreadPoolExecutor that we called over here. Right now, the multiple HTTP requests can therefore be in progress at the same time, and then finally we collect the result and save all the configurations into the JSON file. Now the most important thing, or the most important Python concept that we learned, let me go back to this latest file, right? So let me go to the top. Yeah, so the important thing to understand is that we are not creating 15 complete different pieces of code. We have only one function, which is get running config, right? And we are executing that function concurrently for multiple devices through the ThreadPoolExecutor, which is the new concept that we have learned today, right? So this is a very useful pattern when working with network automation, because network operations are generally inbound and outbound, and while one request is waiting for the NSO to respond, another worker can work on the other request, right? So that's all from my side. So I believe that in this video we learned that the Cisco Network Service Orchestrator is how the NSO manages a multiple platform network, how to access NSO using RESTCONF, how Python can dynamically discover the devices managed by the NSO, and then how finally Python's ThreadPoolExecutor can be used to retrieve configuration from multiple devices concurrently, right? We also have results into a JSON file so that the data can be used for further processing and in the future video we could take this one step further and analyze these configurations automatically, for example looking for configuration differences, generating reports, or integrating the results with other automation systems, right? So thanks for watching this video, and I would see you into the next video. Thanks a lot.